Assalamualaikum and greetings to our lecturers and fellow students. So we are from Group 13 from Universiti Teknikal Malaysia Melaka, UTeM, Faculty of Artificial Intelligence and Cybersecurity, FAIX. We are from BAXI and AI students, section S1G2. So today our group will represent you guys about our project titled Smart Color Detection System for Colourblind Users. So this is an AI project. I'm going to introduce you guys our group members. So we have the leaders, it's me, Muhammad Nabil Muhammad Tam, and then we have Muhammad Shakir bin Abdul Jabbar Tami, and then we have Noor Atira Atilia binti Ibrahim, and last we have Putri Natra Christina binti Halim. So I'm going to introduce you guys. Wait. Okay, so what's the purpose of this video? This video is to represent our AI projects and demonstrate how the smart color detection system works in recognizing colors for colorblind users. How I get this idea for this project? The idea for this project was inspired by the challenges faced by colorblind individuals in distinguishing colors correctly in daily life. Therefore, we developed an AI-based color detection system using a teachable machine to help them improve color recognition. So we are using a teachable machine for the project, and then I'm going to tell you guys about a dataset description. So for this project, we have a 2,809 image datasets. We have 4 colors: blue, yellow, green, and red. The blue one have 749 images. The yellow one have 738 images. The green one have 665 images. And the red one have 657 images. So in that teachable machine, we have 4 colors. So the AI will process and distinguishing the colors correctly. So images of the different colors categorized were collected and organized into separate classes. The dataset was then trained and tested using a teachable machine to allow the model to recognize and classify colors correctly. That's all from me. I'm going to pass to Christina for the model we use and hyperparameters. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Putri Natra Christina binti Halim, and now I'm going to be presenting my part, which are about model use and hyperparameters. So for our project, we use the Google's Teachable Machine platform, which are developed by the Google. And why we use this machine? It is because it can significantly reduces the number of parameters and computational cost. And the advantage of it is it can build for high accuracy on devices with limited computational resources, which like mobile phones and embedded systems. So for hyperparameter, first we use epochs, which refer to the number of times that the model process the entire training dataset. So more epoch can improve accuracy but increase the training time. So here we use 50 and 75. It can allow the model to process training examples multiple times. A second, batch size. Batch size is basically it can dictate training speed, memory usage, and learning stability before weights are updated. And here we use 16 and 32. For learning rate is a floating point number that we set that influence how quickly the model converges. So here we use 0.001 and 0.01. So that's all.
Assalamualaikum and hi, my name is Muhammad Shakir. So I will continue with my part, which is the result of the experiment. So as you can see, we've done 5 trials with 5 different configurations. So the first one we use default configuration and it got 87% of average accuracy. While trial 2 we increased the epochs by 25 to 75, and the average accuracy is increased. However, in the trial 3, we use a default epochs with 50 and increase the batch size to 32. It makes the accuracy become worse because a higher batch size cause fewer update frequency and it cause the inefficient learning. But in the trial 4, we increase the learning rate to 0.01 and we got the best result with this configuration because the higher learning rate to 0.01 it's enable fast efficient coverages, while a small batch size is 16. It's provided frequent and stabilizing the weight updates. And for the trial 5, we increase every hyperparameters to epochs to 75, batch size is to 32 and learning rate to 0.01, and the result is not very good. It's become 73% of average accuracy. So in this page it will show how Teachable Machine works. In Teachable Machine, it's rely on the mobile net. So mobile net does not really actually rely on color. It's rely on shapes, edges, texture, and RGB value. So if the object shares the same shape, then the model is forced into a secondary processing state, which is they rely on the color to make a prediction. But also it got limitation. For example, we've got a yellowish tintas, dim lighting, or warm artificial lighting. For example, if the red color is under the light, it may seem yellowish or orange in the image. So it makes a little bit confusion to the model. Now we go to the real world implementation. As we know that our project is a color detection system. So the first one is visual accessibility. This can help colorblind individuals to know the color, because this project will provide a real-time color detection, and the audio feedback can be provided through a mobile app or something, a wearable device, and this help them to navigate and do a color recognition. And the second one is it may be used also in the industrial automation, because it can almost 100% accuracy and help into the sorting process in the industrial. So it can reduce the manual sorting process and increase the productivity of the industrial. So that's all for my part. Thank you very much.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Atira Tilia binti Ibrahim, and I would like to present about conclusion and the path forward. First, I'm proud to share that our primary objective has been successfully achieved. The smart color detection system effectively classified fundamental colors using a cloud-based transfer learning approach. This successfully validates mobile net's reliability for rapid edge device inference, proving we can achieve high performance on lightweight hardware. Looking ahead, our focus turns to future scalability. While the system is highly effective, we want to eliminate edge case, shadow misclassifications. To do this, the next iteration will exponentially increase dataset diversity. We plan to introduce broader variations in shapes, environmental shades, and complex background conditions. This will make our system incredibly robust and ready for real-world deployment. Okay, now I will demonstrate for the model for using this Teachable Machine. Before that, I will show the advanced setting, which is epochs is 50, batch size is 16, learning rate is 0.01. First model is I'm using my towel because it greens, so I want to detect a green color with this towel. See, it detects 100% of green color. The next is I will show you with plastic roll. My plastic roll is blue color. It detects 100% nicely. The third one is this. I'm using this because this is very big. It detects for yellow. See, it detects 100%. Oh. Okay, the last one is for red. I don't have much thing for red, so I use this for the model. See, it detects 100% of red. Oh. Okay, that's all from me. Thank you.